everyone, welcome to Conquering Algebra 2. We're talking about lesson 33, dealing with complex fractions. This is actually the second part of this lesson. If you want to see the first part of this lesson talking about the three major rules of algebra, I'll go ahead and put the link in the description below. But in this part, I just wanted to talk about dealing more with complex fractions. In this, we see that we have a big numerator and a denominator, and each one has its own fraction. So before we can deal with multiplying complex fractions, which we learned a couple of lessons ago, again, I can put that link in the description below so you guys can reference that. But before we do that, we need to straighten out this numerator. Right now, I have two separate fractions, and I need it to all be one fraction together. So we're gonna have to adjust this. So let's see what that's gonna look like. Okay, so our denominator is not going to change right now, but looking at the denominator of the top part of our fraction, we have a y and we have a yx. So our common denominator needs to be xy, or you could say yx. Looking at the second fraction, we're not missing anything. We already have our x and our y, but in the first fraction, we only have the y, we're missing an x. So we need to multiply by x over x. And this is where the previous part of this lesson, we learned with rule number 3, multiplying by a variation of 1, something over itself, and that's totally legal in the math world, and that's basically what that video covered. So here we have x times x, which will be x squared, and then we have plus, and our second fraction is not missing anything, so we can just leave 4 as it is because we already have the denominator that we need. Now that we have done this part, we can multiply like we learned in a previous lesson where we can multiply our outside times our outside and our inside times our inside. And our outsides will be our numerator and the insides will be our denominator. So we're gonna have y times x squared plus 4 over axy. And then our last step is we want to check to see if we can reduce anything and simplify, and we can by canceling out these y's. So our final answer is going to be x squared plus 4 over ax, and that is it. We're done. All right, so let's do a little bit more practice. Same situation where we don't really have to mess with our denominator very much right now, but this numerator, I need to get this all under one set of denominators. So we need to change this. Our common denominator, so this part's not gonna change. I'm gonna go ahead and rewrite that. So a plus m. And up here, I see that I have a y and I have an x plus y. So my common denominator should be y times x plus y. The reason why I don't just pick x plus y is because this y is not being added to anything. So it is by itself, it's a factor, which is why I have to list it twice. So this first fraction, I have the x plus y, so I'm just missing this solo y. So I'm gonna multiply it by y over y, and a times y is a y, plus, and then this second fraction, it has the y, but it needs the x plus y. So x plus y over x plus y, and so we have m times x plus y. Need to make this a little bit bigger. And so now we have our entire numerator set up as one fraction. Now I can multiply my complex fraction, and I do outside times outside. So we have a plus m multiplied by ay plus m times x plus y over, and then our insides. So x, y times x plus y. And the last step is we want to see if we can reduce anything, but we can't. So this is it, we're done. One last thing that I want to point out, your book actually would distribute this m to the x plus y, so it would be ay plus mx plus my. Either one of these is correct. You don't have to distribute this out because there are no like terms to be added. But either one of these is acceptable, but you do still have to have this a plus m in its own set of parentheses, but either one of these would be the correct answer. All right, and that's it for lesson 33, working with complex fractions. If you have any questions, please be sure to leave a comment below. I'd love to help you guys out. And to my Algebra 2 students, I'll see you guys in class.